Welcome to Number Combinations of the SCUC Catch Fire with Fluency series. The Texas State Standard says that students are to become fluent in mathematics, developing a robust sense of number. This is backed by research and defines fluency as skills in carrying out procedures flexibly, accurately, efficiently, and appropriately. This is directly applicable to problem solving that may take time, effort, and perseverance. This lays out a great task for us to accomplish. Let's take a look at three students. Marcy is a first grader. She determines the sum of 6 plus 5 by counting on her fingers. She extends her fingers one by one, counting them 7, 8, 9, 10, 11. Mac is a second grader. He tackles this same problem using mental strategies, reasonings that he has already developed in connecting to other facts. He knows that 5 plus 5 is 10 and 6 is 1 more than 5. So 6 plus 5 must be 1 more than 10, or 11. Margot, a third grader, immediately recognized this answer. She knows that 6 plus 5 is 11. These three phases, through which children typically progress in mastering the basic number combinations, are important for us to realize, know, and help them explore. Here are some similar addition problems. Now let's take a look at some multiplication problems. These same three phases occur in all operations. Both educators and research support the importance of fluency. The effective, appropriate, and flexible application is an essential aspect of mathematical proficiency. There are three considerations when making decisions about how to accomplish this task. First, how basic number combinations are learned. Second, the cause of learning difficulties. And third, how best to help students achieve mastery. We're going to look at both the conventional wisdom and the number sense wisdom sides of this. How children learn basic number combinations. The conventional wisdom focuses on memorizing individual facts through repeated practice. Phase 1 and Phase 2 are not necessary in this view for achieving the storehouse of facts that is the basis of combining numbers and combination mastery. The number sense wisdom view looks at Phase 1 and 2 as an integral and necessary role in achieving Phase 3. Wow, this is a complex undertaking and requires planning, purposefully meaningful opportunities for discovery in order to achieve mastery. Learning any large body of factual knowledge meaningfully is easier than learning it by rote. Consider, for example, memorizing this 11-digit number. Got it? Still have it? Memorizing this number by rote, even if done in chunks, requires more time and effort than memorizing it in a meaningful manner. Let's look at it again. There is a pattern. Start with 2. If I add 3, I get 5. If I add 3 to that, I get 8. If I add 3 to that, I get 11. Wow, I see the pattern. I got this number. 2, 5, 8, 11, 14, 17, 20. Psychologists state that people, including our students, easily learn a body of knowledge by focusing on its structure than by memorizing individual facts by rote. Children who understand big ideas of composition and decomposition are more likely to invent reasoning strategies, such as translating combinations into easier, known expressions. Children are intrinsically motivated to make sense of the world. Discovery opportunities must be provided. Combination mastery ensures computational fluency. Typically, with practice, many reasoning strategies devised in Phase 2 become semi-automatic or automatic. Learning difficulties have been attributed with the conventional wisdom largely to students' cognitive limitations. Students have sometimes been characterized as inattentive, forgetful, prone to confusion, or unable to apply knowledge to new tasks. What is more likely is they lack adequate informal knowledge. Rote memorization can discourage students from looking for patterns and relationships, which can lead to misapplying knowledge and being less likely to spontaneously invent reasoning strategies. Children need the opportunity to become physically familiar with composing and decomposing numbers, are more likely to invent reasoning strategies. The conventional wisdom approach for ensuring mastery of number combinations is extensive drill and practice. Phase 1 and 2 of number combination developments are still seen as largely unnecessary steps for or even a barrier to achieving Phase 3. The National Research Council recommends that the efforts to promote computational fluency be intertwined with efforts to foster conceptual understanding, strategic mathematical thinking, and a productive disposition. is a tall order. The question for us is, how are we going to make this happen? There are 4 instructional implications based on current research. Keep in mind that number sense is not something that adults can easily impose. Help children gradually build up big ideas such as composition and decomposition. Children typically adopt more efficient strategies if their number sense expands or when they have a real need to do so. Instruction should concentrate on fact families, not individual facts. Focus on how these combinations are related. Encourage students to build on what they already know. Different reasoning strategies may require different approaches. Research indicates that patterns and relationships differ in their salience. Use practice as an opportunity to discover patterns and relationships. Practice should focus on making reasoning strategies more automatic, not on drilling isolated facts. The learning and practice of number combinations should be done purposefully. Purposeful practice is more effective than drill and practice. Remember, conceptual understanding of written arithmetic comes through the counting and reasoning phases. Game it up. Students should be encouraged in, not discouraged from, flexibly using a variety of strategies. Achieving computational fluency for our students is going to come from meaningful, inquiry-based, and purposeful instruction. Children who learn basic combinations in such a manner, focusing on phase 1 and phase 2, will have the ability to use their basic knowledge accurately and quickly, thoughtfully in both familiar and unfamiliar situations, and inventively in new situations. Let's talk about number bonds. A number bond is a tool that can be used to help students explore and discover number combinations. No longer are there 4 different operations of addition, subtraction, multiplication, and division. With number bonds, a child sees that addition and subtraction, or multiplication and division, are simply 2 sides of the same coin. Take a look at this teaching chart that helps explain the number bond concept. Now, take a look at these examples of how number bonds can help a student solve a word problem. Here are some ways that you can use number bonds. What's missing is the first way. Circle either addition or subtraction or multiplication or division at the top, and then fill in 2 circles in each number bond like the example. Your students will then need to fill in the missing circle. Next is the same whole. Circle either addition or subtraction or multiplication again at the top. Then fill in the top circle and one of the circles in each bond, making sure the whole, the top circle, is the same at each time. The third is add-ins and factors. Have the students fill in all the possible add-ins or factors. Use the parts for addition and multiplication for a particular number. For example, give a child the number 63 for multiplication, and he or she has to fill in the possible factors, the parts for 63. A number bond is a mental picture of the relationship between a number and its parts that combine to make it up. The concept of number bonds is very basic, an important foundation for understanding how numbers work. A whole thing is made up of parts. If you know the parts, you can put them together to find the whole. If you know the whole and one of the parts, you can take away a part to find the other part. This session is followed by number bond make and take session that will provide you with tools to help students discover number combinations through physical practice and game application. This is just the beginning. There are many other options for using number combinations to help students learn.